pair of Diel-alder problems here. Try drawing the structure, the product of the first one, and the starting material for the second one. And then talk it over to the person sitting next to you. And then we'll see what people think in terms of answers. Can we just go ahead and use this the way it's drawn? No, this is what's called the S-trans conformation. We can rotate about single bonds. It needs to be in the S-cis conformation. It has to look like that. The top one is doing this. We need it to look like that. So we've got to rotate about the central bond.
Do you want us to indicate that on the exam, or would you like to?
Well, to help you solve the problem,
Yeah.
get it correct. So I would redraw it just to help you. So what's going to be off of, let's see, 1, 2, 3, 4. 1, 2, 3, 4. What do we have to do to carbon number 1? Okay, I got to put a methyl group on it. And where's that methyl group going to be?
Cis to the methyl group on carbon.
What kind of an alkene is this? Is it a cis or trans? It's a trans, so where do we want to put the methyl group? trans. So that would mean it's up or down? Up. So our methyl group is actually up here. Is that okay? It's trans here, we want to draw it trans here. So hydrogen is down. And then we have a hydrogen over here on number 2. Is that all right? Okay, how about carbons 3 and 4? What do we have to do here? That alkene is trans. And so from here to the double bond, where's the methyl group going to be? Down. So our methyl group is over here. Okay. We now have the diene in our right conformation. And we have to draw it that way, or we might get the wrong answer in the structure of our product. And what do we do next? If that's our diene, what else do we need to do to map out the structure of our product?
Add your 5 and 6 to your diene.
So add 5 and 6, and up here it could be 5 and 6 or 5 and 6. We can do it either way. We'll probably get either diastereomers or enantiomers. So we'll number the top one 6, the bottom one 5. So what do we do now?
Make your 6 carbon ring.
6 carbon ring.
Double bond,
1, 2, 3, 4, 5, and 6. Double bond between 2 and 3. Shrubbery. I'm not going to, you got to tell me what to do. I'm not going to.
Well, 6, there's the methyl.
6, there is a methyl group. So, all right, CH3.
And then the ring that attaches 5 and 6.
Okay, what size ring?
It's 1 carbon, oxygen, carbon.
So 5-membered ring. Are we done? Got methyl groups on 1 and 4. Done? No.
Do you want to draw hydrogens?
Sure. Some of them are more important than others, but sure. Stereochemistry. Right now your answer is 3 to 4 points. You're missing an awful lot of information in your structure. So help me out here. How do I indicate stereochemistry here?
If you want to make everything on one side, you can make the 1 and 4 methyls on going up on a wedge, I guess.
Okay.
And
So these are wedges. Why are they ending up being on wedges?
I don't know how to explain. I just know that those needs to be the same because they're coming from the same thing. 1, 2, 3, and 4.
So when we do the Diels-alder reaction, out and out are on the same side of the ring. In and in are on the same side of the ring. We have to look at models to really convince ourselves of this, but that's the way the Diels-alder reaction works. It's a syn addition to our diene. And a syn addition causes those two groups to both be up on the ring. All right, you're better. You're probably 4 points out of 6 now.
So the carbon bonds off 5 and 6 would be both
Okay. So 5 and 6, we either put both of these groups down or both of them up. And at this point, you probably have 5 points for the answer, because you really should draw the other one. What's the relationship between those two molecules? They're diastereomers. So if they're diastereomers, you really should draw them. So the Diels-alder reaction could lead to enantiomers, or it could lead to diastereomers. If it leads to diastereomers, go ahead and draw them. Half the molecule is the same, half the molecule is a mirror image. They're not mirror images, they're not the same, they're diastereomers. So we draw them. Full points. All right?
I have a question about,
Yeah.
so we had to change the structure of this. How did we every time it looks like that, we know that we have to change it, or?
You see the central bond, carbons 2 and 3, and the double bonds are doing this. Know that you have to make them like that. They have to be on the same side, because we need to make a ring out of them. As it is now, we can't make a ring, because they're pointing in opposite directions from one another.
Mm-hmm.
So you need to rotate about the central bond. There was at least one example on the problem set for Diels-alder where you had to do that. So you might practice those problems again. Okay, any other questions about that one? Okay, how about the other one? Going backwards. We've always loved going backwards. Remember ozonolysis and going backwards? It's kind of like synthesis going backwards, which we also love to do. Yeah. Michael?
This one has 2 answers, right?
This one has 2 answers. You're right. There's one answer that's better than the other answer, though. So what are the 2 answers, Michael?
Well, one of them can be, you have the left side be the diene.
Okay, so either the left side could be the diene, or the right side could be the diene. 1, 2, 3, 4.